I'd like to thank Engage first and foremost for once again providing this awesome facility and doing all the hard work behind the scenes to make these things happen. It literally wouldn't be happening if we weren't getting all the help that we get from Engage. So thank you, Leslie. Thank you, Phil. Where's Phil? Phil. And Robert, thank you for helping organize and get these speakers lined up and these topics on the agenda. It's actually harder than it looks. And a few announcements. We've got Momentum conferences coming up. That's October 17. And we have a discount code of APISEC, API-SEC. If you don't already have a ticket and want to, you can get a discount by using that code when you buy your ticket. Is there any other meetups, software craftsmanship, anything like that coming up?
Yeah, there's the C3 meetup that Engage hosts in this space next Wednesday. So that's a, pairing, do some code exercises, kind of geek out that way. So that's the third Wednesday of every month. And there's also this coming weekend, Southwest Ohio Give Camp. So if you want to help some nonprofits, you could sign up for that and give up to the whole weekend or a fraction of the weekend to use your technical expertise that way.
Awesome. Thanks, Phil. And then we're also talking about trying to potentially host this meetup next time at 1819, the Innovation Center down in Cincinnati, to try to just get it in another location that might be more convenient for different folks. So we'll try to do that when we get our keys to the new BTD building over in Kroger, and once we get through some of the things that are keeping us from hosting. So we'll try to move it around. But if you are from some area that you would, like up in Dayton or anywhere, and want to host one and, speak at it or anything like that, please come talk to us because we'd like to spread it out a little bit. All right, without further ado, I would like to also thank Kong for letting Damon come here and talk to us about Service Mesh. Service Mesh is an interesting new trend in technology that probably creates as many problems as it solves. I don't know. We'll find out.
Yes, you're possibly correct, depending on how you do it. Sure.
So without further ado,
Thank you. Thanks, John. Appreciate it. Thanks, everybody, for having me. Leslie, Phil. Damon Sorrentino, solutions engineer at Kong, specializing in API management software. So we're here to talk about software modernization with Service Mesh. My slides are pretty light. I'm going to do a demo today, kind of just to show you, what it's all about. It's, you engineers like to actually see stuff work rather than doing slide work. So here, have any familiarity or any with Service Mesh? Show of hands.
Buzzword.
It's a buzz. It's not a buzzword. It's a deployment pattern is what it is. It's a deployment pattern for implementing modern networking and connectivity among different services that make up an application. What does that mean? That means it is it's a software-defined network, right? It's an overlay on top of your network. It's not a developer tool. It's more of a networking. So networking guys, really like to use a service mesh, right? It's a layer 4. Historically, it's a layer 4 tool, right? So you're going to use a service mesh to communicate at the socket layer. Your applications should not know it's there, right? As indicated here, each service is deployed with a sidecar, and that sidecar intercepts all traffic over local-host, right? And typically, service meshes are implemented with Envoy. There are a couple implementations that write their own sidecar. I think Linkerd. Linkerd is one that has its own. They wrote their own sidecar, but primarily, everyone uses Istio or Envoy. Istio. Kong has an open source Kuma. We use Envoy as the sidecar for proxying traffic. So why is it? Why do you use a service mesh? Because you don't want a point-to-point connection from service to service. I want to be proxying. Everybody knows when you use a proxy, like using a gateway, you can do all sorts of interesting things when you're proxying traffic through something else. I'll give the next slide. Will have the 4 pillars of what happens with a service mesh. But with a service mesh, you can encrypt traffic. You can do all sorts of cool stuff that can't do when you're talking service to service. Now, obviously, when you introduce a proxy, you're going to introduce some processing time. So Envoy is a pretty performant proxy. It doesn't add much overhead. I think we calculated it out. It's probably like 2 to 3% that you add on to when you're using a service mesh. So there's other ways to do it, but a sidecar offers you a lot of flexibility. A lot of the buzzwords now, ambient mesh, and there's current eBPF, there's kernel level stuff where you don't have to have sidecars. But with a sidecar, you can get a lot of flexibility that you wouldn't be afforded if you're at the kernel layer. So, any questions about what a service mesh is? I like to kind of keep these things interactive, so I'm not up here just talking at you. Cool. All right. So, why do you use a service mesh? I mean, you kind of touched on it. There's 4 main pillars that you kind of usually use with service mesh. Service discovery and connectivity, right? When you're in the service mesh, you basically, it's a network in a box. You have DNS, you have all the tools that are self-contained. So every service knows about each other without you doing anything. It's service discoverability out of the box. ZTA is your favorite word. I said ZTA, I didn't use zero trust. Zero trust architecture, right? That's another one of the things. It's it's a thing. Traffic reliability. I'll show you. In my demo, I'm going to show you some of how ways traffic is reliable across networks, across clusters and things of that nature. And probably one of the most important things is observability, right? I want to be able to know which services are talking to each other, latency, all sorts of. Envoy has just a wealth of statistics and metrics you can use to troubleshoot all of your applications and things like that, that you get basically for free when you use a service mesh. So that's the 4 main pillars. So first one is service discovery. I kind of hinted on it. Automatic registration and deregistration from the mesh DNS result. Right. So the mesh has its own DNS system built into it, and when you register a service inside of it, it tells the control plane, "Hey, I'm here." And then what happens? The control plane then does its thing and sets up. In the Kuma, the open source, you see we have this .mesh addressing scheme. So every service in the mesh has a .mesh address, right? So I don't care where the service lives, what hardware it's on. I just need to be able to reference it by its DNS name and a port. And so each service is backed up by a set of data plane proxies. So what happens is I want to say if I have Redis on the mesh, in my application code, I'll say redis.mesh. I want to connect there. And it'll just connect to whatever Redis is closest. And then if that fails, it'll just go find another one. So service discovery, that's kind of.
What if you don't want that?
What if you don't? Well, if you don't, that's a good question. The question is, what if you don't want that? Well, your service discovery, if you don't want it to fail over, there's different policies that will allow you to go just local and just stick to your own zone or things of that nature, and it won't go out. So you can control it by policy. Does that make sense? Yeah. Cool. So any other questions about service discovery?
In your experience, what's the overhead of the service discovery and the chattiness of checking to make sure that address still exists?
I mean, I didn't see too. I mean, any other. Yes, there are tweaks you can put inside of certain implementations that propagate it down, and you can tweak those things. Yes, the DNS chattiness.
The question.
Oh, sorry.
On that, yeah.
So what was? Because repeat it to me, and then I'll repeat it. Sorry.
What is the overhead you've seen of that chattiness of service discovery and health checking to make sure something still exists?
Right. So the question is, what is the overhead for this? What is the chattiness of the DNS and all of these service discovery mechanisms? And I would say that it's just as much as any gateway, because it's a proxy, right? Granted, you're doing it, for each proxy is doing it, but your control plane is, you can scale your control plane up too, right? So it doesn't have to be a single control plane. You can kind of schedule that.
But in contrast, though, if I'm doing an internal gateway for that type of thing, I may only have 5 of those instances where every app has a proxy that's doing it. Now
Sure.
I'm just 10 plus.
Agreed. So the question is, yeah, using a gateway instead of that, sure. It's a trade-off, I would argue. Everything in our world is a trade-off, right? And if you can measure it, then you can take the appropriate measures to overcome that. Because with a gateway, you're stuck configuring that stuff manually and things of that nature. With a service mesh, it's done for you. So what's the trade-off between that chattiness that you can control? So that's how it. Does that make sense? Cool. Good question, Robert. Thank you. I'm sure there's going to be many more. All right, cool. Service discovery. Next, zero trust architecture, ZTA. So the overall overarching theme that a lot of people say is, how do I control security? And this is API Security Meetup, right? So the mesh, by default, is as locked down or as open as you want. And it's all controlled by policy, right? And so trust nothing by default, establish strong identity verification, and validate prior to granting access, right? Those are the 3 pillars of zero trust architecture. And with service mesh, you get all of that out of the box, right? You can enable MTLS. In other words, each data plane proxy will, so in Kuma, for instance, most meshes, I think, have the concept of its own CA inside of the mesh, right? So a data plane will go, all right, I'm going to talk to the control plane, give me a certificate, and then I'll be able to rotate, expiration of the certificate and things of that nature. So out of the box, all of your traffic between services is encrypted and protected by mutual TLS. So the client has to present a certificate and the server does. And so every service has that capability. So your traffic is encrypted across the mesh by default. You can turn it off and on, most systems. But then you can also, this graphic to the side is just a policy. You're able to, it's a software overlay, network overlay. I'm controlling everything at layer 4. So I want to be able, in this thing, I want to be able to say, hey, this system, this service can talk to this service by default, or it can't. Service A may have all the credentials necessary to talk to service B, but if I explicitly say at layer 4, no, you're not allowed to do that, then you're not allowed to do that. A use case may be, what if you have a PCI application that, and you only want very certain services to be able to talk to that PCI application. Okay, so you can, with the service mesh, you can apply policy and really define very granularly that which services can actually talk to that PCI application. And it's very easy to control. You just apply a policy and it just does it. So ZTA. What else? Validate, and there's also lots of policies that you can do fine-grained authorization as well, right? So, if a common authentication scheme is token-based auth, right? So bearer tokens are passed from service to service. So I want to be able to authorize, which service A calls service B. I'm like, oh, okay, what roles do you have inside of your token? Maybe I'll grant you access and maybe I won't. Okay, you can do all of that stuff in a lot of service meshes as well, using some OPA, like Kong has a OPA, Open Policy Agent, built into the service mesh. Envoy allows you to hook in an Open Policy Agent. Anyone familiar with OPA? Yeah. So you can apply those Rego files to your data plane proxies and then do fine-grained authorization with services. So the goal here is to operationalize authn, not C, right? Let's not build that stuff into your application. Let's externalize that so you can control it without having to modify your application code, right? So OPA helps with that, and it's the SecOps people's dream, right? You don't have to, you can audit it, you can control it, you don't have to change things. It's very efficient.
So Damon,
yeah.
the thing that's always appealed to me, at least, I don't know, do I need to be on the mic for the recording? The thing that always appealed to me about a service mesh, at least philosophically, was that abstraction, right? Especially when you look at some of the complexity that like we have, right? You've
Yeah.
got on-prem data centers, you're in Azure, you're in GCP. These services need to talk to each other. There's some form of an internal network in all of this
Yep.
that is supposed to be internal, and it's very complicated because whatever application team is, wherever their deployment was, which data center or whatever, they're going through a different set of firewalls, a different set of load balancers. It's just not the same ever.
Right. That's right.
And that software-defined networking over the top of it makes configuring all of these things to talk to each other the same. So,
That's right.
from a configuration and operation, it sounds wonderful.
Yep.
But the part that scares me,
practice.
and again, just I have no experience with it, so I don't know, but that seems like a giant potential single point of failure. Like if your mesh goes down, or if
Right.
things aren't working correctly. Most things that you abstract away, you're hiding a bunch of detail
Mhm.
that might be important to understand and know if things aren't communicating properly. So
Right.
like never seeing a large scale production mesh in action. I don't know how that works. And
Yeah.
does it obfuscate these details, or does
Well,
it make it easier to troubleshoot?
It's a double-edged sword.
Yeah.
Right. It always is. When you're, let's take the resiliency thing. If the mesh going down is not really a thing. It's if your application goes down, then that mesh is going to go down because that sidecar is attached to your application. Right. So the mesh is ingrained into your infrastructure. Now the single point of failure is those network endpoint. I want to talk from data center A to data center B in an east-west fashion without a gateway, right? So you want to make that connection between the networks redundant. That's all, right? So if I have, in how Kuma does it, or open source, is you have a zone. I'll get into this in the demo, but you have a zone ingress, right? That is that single point of entry from network to network. Right, and so enterprise grade service mesh, I like to call it, is like historically service mesh is a flat network topology, right? Everybody can see each other. As you mentioned, that's not the case because you'll have multi-clouds, you'll have different networks within. It's not flat, so you have to somehow connect those networks, and you do that, and everyone does that with classic switches and opening firewalls and things like that. And with a mesh, you still have to do that. But you only got to do it in one spot, right? So you'll open up, in Kuma, you have a zone ingress, which everything gets multiplexed over port 10,000 to that network. So all traffic from the mesh will flow from one data center to the next to the zone ingress point. And that zone ingress point can be redundant. So you can have multiple, it's an envoy proxy. And you can have multiple envoy proxies fronted by a load balancer. So if one of those proxies fails, it's just going to go to the other one. So that resiliency is you build that into the mesh itself. Does that make sense?
Yeah.
Right. So and as far as if the control plane goes down, that's not a huge deal because the control plane is just a traffic cop. It's just a configuration manager. Right. If that thing goes down, you just have an alert. Hey, your control plane went down. You have some stand right back up, and everything just kind of goes. Okay, but your traffic is not affected. It just kind of continues to go because the data plane proxies are the thing that's actually doing the traffic management.
If you stand up a new control plane, so we've been talking about a similar situation based on the Azure Central outage that happened, and how much fault tolerance do we need to put into the control planes, right? Since they're just doing configuration, the traffic will still flow. But you could be in an extended outage where you need to change routing and reconfigure things and get things routing somewhere else. So, how plausible is it to stand up, spin up another control plane in another region and connect to
Yes. Well,
everything?
yes. I can answer that from a Kong perspective, but I won't. From the so you can have redundant control planes, but you're going to have to change your if you're in a multi-zone mode, you would have to change. Okay, I need to point to this, or you would have the global control plane fronted by a load balancer, right? And you'd have multiple. You only have a leader, right? So if it's the same thing as the ingress. So if you were hosting the global control plane yourself, you would have, and so what happens, the zones report back to the global. It's a hub and spoke kind of thing. So if you had, 4 or 3 global control planes fronted with a load balancer, only one of those control planes is active at a time, doling out all the configuration. If that thing goes down, a new one gets elected, but it's still talking to the same load balancer. That's how you do it. Does that make sense?
How does that election work?
I mean, it's up to the implementation of the mesh. However you do that. Ours, I don't know how we do it in ours internally. I don't know. There's in Kubernetes. There's some. I'm not privy to all the details. I don't write the code, but I know that it doesn't. But it's Sophos mesh implementation specific. Any other questions? Thanks, Jeff. It's good. Very good. Good question. Not quite zero trust, but that's all right. And then traffic reliability is the third pillar, right? This kind of gets into what we were just talking about. I want to be able to, I have 2 clusters, east and west, and I'm replicating service A, B, C, and D across both, and I need to be able to be resilient across these network boundaries, right? Service mesh allows you to do that, because what you're doing in service mesh is essentially you're doing client-side load balancing. That's one of the magic things. All those little envoys know where to go. And it knows, hey, if this guy's down, I'm just going to go here. So as opposed to a gateway where you're doing everything on the server side, and when you're doing client-side load balancing, it gives you a little more flexibility.
Can it support something like an active-passive type pattern? So, there are potentially application teams, across a large organization that don't necessarily need to be in multiple regions, and some that do, and some that do, but not need to be active in multiple regions, but just have like a backup in case disaster happens, right?
Yeah.
Will it support patterns like that where, it's gonna favor one,
So
region, I guess, unless it's down?
yeah, so the question is, does your traffic reliability need to be active? Essentially, I want the ability to fine-grain control my, traffic reliability shaping, and the answer is you can. In Kuma, there is a load balancing strategy policy that allows you to configure very fine-grain. I want zone A to always stay here until a failure happens, and it will just maintain there. And then you can even fail over to. I want to go. These 2 data centers until one of these fails. So there is a policy. So Envoy has a very robust load balancing. We just piggyback off of Envoy load balancing, right? So, and then we kind of abstract, the configuration away from you. So you don't have to, because configuring Envoy is, I don't know if anyone has ever done it manually, those configurations get to be about a mile long. So service mesh is abstracting that. So we piggyback off the Envoy load balancing stuff, and you can control. It doesn't always have to be active. It'll just fail over. And then you can actually write, I'll show it in the demo, but there is a mesh TCP route policy. I can say I want 100% of the traffic to go here all the time. And then I can say, all right, now I'm going to change that manually to go 50-50. So you can control it. Does that make sense? Yep. Okay. Cool. So traffic reliability, that's cool. And then the last pillar, before I get into the demo, is observability, right? I need to be able to know which service is talking to what. I want to monitor service to service. I want to be proactive in my troubleshooting instead of reactive. I got, with good observability tools, you can see when problems are going to happen. And you have the, the whoop whoop alert machine go off. Hey, gonna have a problem. And then this obviously reduces your mean time to resolution when you have good observability. And the service mesh just enhances that. Right? There's traffic metrics. There's tracing, so you can build in open telemetry. A lot of open telemetry insights. So you can really instrument the mesh, and if your applications also do open telemetry, you get a real, and from the gateway to the mesh to all the services, you'll have a very complete picture of what's going on inside your whole system. Because if you're going to microservices and if you don't have an observability strategy, you're going to fail, because it opens up a whole can of worms when you start writing all these little services. because you don't know where things are going. I mean, it's great for, microservices are great for developing rapidly, onboarding app developers quickly, but you can get yourself in a pickle if you don't know how to observe your whole system. And a mesh can help with that. But there's no substitute for actually instrumenting your code too. We can't help you if you don't do that. So, does that make sense? Questions about observability? I think everyone just kind of understands observability is important. Cool. All right. Demo time. Let's do a little live demo. I do this demo a lot. I think, John, you've seen it. A lot of people have seen it, but it's a fun demo. I'm going to be using our service mesh implementation, Kuma, because that's what I know. Excuse me. All right, let me get myself set up here. I have to reboot my machine, so I got to bring up all my applications. All right, the first thing I like to do is show a little picture. I'm just going to go to our Kuma.io docs. Let's see here. Deployment topology. Okay. Start with a little picture first. It's in full screen. So what I'm going to be demoing is this. This is a distributed multi-zone service mesh that spans networks. This is the complex situation where I may be multi-cloud. I may be in Azure, I may be in AWS, I may be in on-prem Kubernetes and non-Kubernetes, right? So what this picture represents is each of these boxes are a zone or a cluster or a network boundary. Yep. West, east. And on top, you see a global control plane, which is the place that manages all the different zones connected to it. Right? So there is a zone control plane in each zone that is responsible for registering itself when you bring the zone online with the global CP. The global CP has all the DNS information that it propagates everywhere. And each zone can communicate with each other using these zone ingress and zone egress components. So if this service needs to talk to that service, I don't need to know specific host names. I just need to know a service name. Now by default, this service may talk in the zone itself. But if this service fails, it needs to know how to go somewhere else. So what's going to happen is it's going to say, oh, this guy's down. I'm going to go through my egress and control how traffic exits the zone to the ingress, and it knows, oh, I'm going to go here. So the service mesh kind of takes care of all that routing. It's all built into the smarts of this sidecar, of the Envoy protocol. Okay.
Does that mean every sidecar has to have the entire routing table?
Yeah. I mean, it's Delta. I mean, it's that light is killing me. They're all different. They're depending on which services are configured. But they do get large depending on how complex your mesh is. Right. But it doesn't have everything. So if I define routes, like there's like a mesh TCP route protocol. If it will only configure the routes for stuff that it knows about. So you want to be when you're defining a service mesh, you want to be as very particular as possible. You can't do star.star a lot of times because then you wind up with this huge mess, and that's when you get into the chattiness and things of that nature, right? It's like any software. Good design, there's no substitute for good design. Bad design, you got to design it. If you just throw a big sledgehammer at it, yes, garbage in, garbage out, right? So you really have to understand what the mesh is doing to develop it effectively. We always recommend people to start very small and then scale larger.
What's the largest size mesh that you've seen?
We have a customer that is using Kuma actually. It's got 15 zones over the globe, and it's a legal firm, and thousands of requests. I mean, terabytes of data, and they use that, and there's 15 zones across the planet, and It's a very large implementation.
Multi-cloud, hybrid?
No, they're mainly on Azure, I think, but all over the world. What's that?
I said, of course they are.
Yes, of course they are. Yeah, so I've seen some pretty big implementations. We got one customer that's going to be huge as well. Can't say the name, but we're going to get up there.
So is there a law of diminishing returns on the size versus chattiness? Like, can you get, like, is there any kind of best practice, or does it really depend on how you're configuring the zones and the amount of
Yes,
traffic?
the question
and data
is,
and
yes,
size of data?
Yeah, is there best practice for setting up these things? And it really depends on your infrastructure. There's never a one size fits all for this stuff. It's very specific to your organization's application architecture and things like that. So it's best to get a nice,
I mean, if you go back to last month's conversation on API gateway segmentation, the same concerns are there too with service meshing. Is how do you segment?
Yeah.
It's never usually one mesh. It's usually multiple smaller meshes, but the mesh to connect to the other mesh is there. It's never one solid total mesh.
That's right.
So
So what's the impact on the average developer? Is
It
the
should be
average-
zero,
Okay.
right?
until there's a problem.
Until there's a problem. But you do have tools to. It's always a connectivity problem. Always. It's some miss. But see, usually it depends. See, a service mesh is tricky because it's like I said in the beginning. It's a networking tool. Developers, only thing they need to know is who am I going to talk to? What's the URL I need to talk to? And that's it. So service mesh operates at layer 4. So when you're implementing service mesh, or any new technology, in my experience, it's all about trusting that technology, right? I need to trust that it's and developers, it's like there's a performance benchmark that you have to hit. I shouldn't know it's there, right?
But CTA.
Yes. So with that being said, Kubernetes makes it a heck of a lot easier, right? Because Kubernetes orchestrates all those sidecars and things of that nature for making this as transparent as possible to you as a developer. I'm a developer, and there was one project I did for a customer of ours. I think I was tasked with I was doing a demo, and I was a POC, and they said, all right, we want to use the robot shop, and that robot shop is a public GitHub repository of microservices that it had like MySQL, Mongo, PHP applications, and everything. It was a e-commerce for doing for buying robots and things like that. And this company's like, I need to have that inside of your mesh as a demo. All right. So I'm like, all right. So I forked the repository, and I'm going to make this Kong meshable. I'm going to do it. And I found when I did it that I didn't have to change much of the applications to get it into the mesh. I just had to change some configurations. But the ones I did, I'd look into the code and it's like, well, that was written very poorly. So if your applications are written poorly, you're probably going to have to change them. But if they're not, then, like I got MySQL in the mesh, no problem. MongoDB, no problem. There were some Java applications that had some hard-coded things in there. I'm like, all right, that's a problem, right? Different ports and things like that. Because when you do a mesh, in our world, all you have to do to be on the mesh is you change your endpoint and the port. If you're using our service discovery, it's always going to be port 80, and it's always going to be some .mesh address. And the Envoy proxy handles all the TLS-ness of it all. Okay, so it took me a couple months to get it on there, but in the end of the day, I had it working, and I had to make a couple changes to different applications that had hard-coded stuff and things of that nature. But there was no complex changes. Does that make sense? Long answer to a short question, but I have had real-world experience doing it. You can do it without too much difficulty. You have to understand what's going on. So, does that help? Does that make sense? Question? Yep.
How does it handle the auto scaling? Like if we are scaling the instances for one service,
Yeah.
is it gonna go during it? There is a time for spinning up the instances.
Right.
Is it gonna go through the other way, like as a payload?
Well, the question is, how does it handle auto scaling? And the answer is it depends. So we don't auto. That's up to the auto scaling is dependent on your infrastructure, right? So if you're in Kubernetes, you have your horizontal pod auto scaling. So we're agnostic. We don't do that in calling mesh. That's all implementation specific outside of the mesh. So however you do it, that's how it's done.
But those services have to register with the mesh if they were additional services.
The proxy registers. The service doesn't. The proxy does. Right? So when you stand up the data plane proxy, in Kubernetes it happens automatically for you. But if you're in universal mode, so Kumo will run outside of Kubernetes. Right? So, I mean, if you think about all you're doing with a service mesh, is you're standing up an instance of Envoy, standing up an instance of your application, and converting IP tables to say, okay, I want to intercept this traffic from application. Instead of going, if it references an external address, it's going to get that, intercept it, and go localhost. Then the Envoy knows to go out to that other application. So you're basically just running two applications on a machine. So you have to write automation to do that, whether it's Ansible or whatever. So if you're running VM workloads, you already have some kind of automation in there. So to do a service mesh without Kubernetes, you're going to hook into that existing automation infrastructure, and then learn a lot of stuff. That's why it's a networking tool. We've had some very complex POCs that for universal mode mesh, and you run into all sorts of weird problems because like Red Hat 8 does weird things. You can't use IP tables. You got to use some other version. So you can get into some pickles, and it takes some time to sort these problems out. And it may happen, but you can. I have not been in a situation where I couldn't run it. It just takes some time. You got to be able to get into the nitty gritty and really solve the problems. Yeah.
So in some of the clients you've dealt with, is it typically the network team that sets this up, or developers, combination of both?
Yes. So the question is, who sets up these things? And it's usually the network team and the DevOps teams. Software developers, they're generally not involved in these POCs until afterwards, and then they kind of come in after the fact. But yeah, we're dealing with DevOps and network people. Any other questions before I actually demo the stuff? Cool. All right. So I'm going to demo this, and what we have is we're going to be running in GCP. I've got 2 clusters here and a failover cluster. So I have east and I have west. Those represent those 2 boxes you see on the screen. Okay. And what we have is a very simple application. It's a gateway in front of a Node.js application talking to Redis. Right? And Redis, all of these applications live in the regular zone and the failover zone. So under normal operating, so you see, here, the browser, demo app, Redis. There's a gateway in here too. You just don't see it. So if I hit auto increment, you're going to see that I'm going in through the main ingress point, and it's just kind of bouncing from east to west, Redis by default. Right? I can open up my failover URL. This is going through a different gateway, and you can see it's doing the same thing. Right? It's gone JKE East, JKE West. Very cool. It's great. Now, one use case of the mesh is I want to be able to do that manual active, passive, active thing, right? So I'm gonna, I forgot to, let me pull down my context here to connect to my demo zone. What is this? This one? No, it's this right here. Sorry. So I'm using our gateway, our mesh, so it's gonna be a little column specific. So I'm gonna connect to that global control plane right now. So when I apply policy to the mesh, we're gonna apply policy to here. We'll apply policy, it's going to propagate down all the connected zones. So what I want to do is I want to get that. So what I want to do is I want to bring down, I want to do some maintenance on GKE West or East. I can't remember which one I did. I'm gonna do some maintenance on one and temporarily route to one of the zones while I work on the Redis. The other one. Okay. So how we do that? I'm gonna bring up. I'll show you the policy what it looks like. It's kind of self-explanatory, but let's see. Okay, is that visible? Is that, should I make it bigger? We see. That's pretty cool. All right. So what this is a typical policy in Kuma. All right, this is our counter failover route, and you can see type mesh TCP route, and what it says is, okay, I want the target of this to be the counter app. These are service names, okay, and I want to the source of the information of the request to the destination, which is Redis. Okay, what I want when I apply this route, what's going to happen? It's going to say, okay, give me a subset of services that name is Redis and are tagged with GK East and tagged with GKE West. I want to say, give me 0 to East and 100% to West. Okay, so I can go over to my command line and I go to my directory that has that. Projects. Close down this. Yeah, right there. Let's see, demo framework. And it's demo policies, mesh. Okay, so here I have this route to failover. So in Kuma, we have a command line program called Kuma CTL, which is like Cube CTL. I'm basically going to apply that failover policy to my global control plane. Now when I go here, I'll give it a second. There you go. Not going east. Just apply the little YAML file and it adjusted all those Envoy policies. Now I'm free to work on Redis in the east, do my stuff, and then all I need to do to go back to normal operating is just delete that policy. Let me get the name.
Now, with the 0 and 100, what if the one that's listed as 100 goes down? Does it default back to 0?
Well, then you're screwed if you only have 2.
Well, but I mean, if in the load balancer, one of the gateway problems where Kong and other ones differ is there's not an active passive mode with Kong. It's based on weights.
Right.
And a lot of those times when 0 weight is ignored because it's not sending any traffic, but when the other nodes that are 100% weight fail, it should default back to 0 and not always.
That's a good question. The question is, if the 100% one goes down, what happens? And I don't know the answer to that question because it's an Envoy thing. I don't know how Envoy handles that. So we can just read the Envoy documentation and it should tell us.
Okay.
But I don't know off the top of my head. Sorry.
No, not a problem.
But I had an answer where to look. All right. So to simply if we want to go back to normal operating, let's say delete mesh TCP. Oops. We're just going to delete the policy. I think that's it. Boom. And now we're back to everything, back to normal operating procedure. So you see the software-defined network is cool. It's just real simple. If you were to do that under like normal, you'd have to go to your network administrator. I got to adjust this DNS. I got to do a bunch of stuff. To do it, you can just do a single policy. Yep.
You have 2 different
Yeah.
Servers are connected.
What's that?
What's that?
There's 2 different instances of Redis.
Okay.
So Redis is storing this zone. It's just the key value. There's a zone key in Redis, and Redis is running in the east part of the United States and the west. And this thing is just load balancing across different Redises.
The 2 Redis clusters are not connected.
No, they're not connected. There's no cluster. Yeah, right. I didn't get that cool in our demo. I mean,
That's a pain in the end.
it is. It truly is a pain. Yes, that's a complex problem. Then you got to replicate and do all sorts of stuff. It's demoware, guys. It illustrates a concept.
Yeah.
All right. Cool. Now, the next thing is you'll notice it's pretty slow. Like it's doing a lot. We've abstracted a lot. I'm abstracted clouds. So I want to be able to have locality, right? I want east to talk to east and west to talk to west. So I can have, your workloads are close to each other. So that's another simple policy that you can do in Kong Mesh or in Kuma. All right, what is it? Enable locality, right? So basically, what this says is, in any mesh, disable or enable locality awareness. This is something built into Kuma. I don't know how the other meshes do it, but they should do it. I don't know how they do it. So I'm just going to say Kuma CTL apply -f. Is it 05? Enable locality. Oops. Also, I know how to type. Go. Now, give that a second. Oh, look at that. Now east is going to east. I'll go to my western ingress point. And they're talking west. So this east and west. All right. Now, catastrophic failure happens. East goes down. We want to be able to automatically fail over. So we can simulate that because we're in Kubernetes, and we can easily do that. We just set this up. I like doing this live. Where's the scale? Okay, so we can scale. So if I have this scale, so I'm going to scale Redis down to 0. So let me.
Is there any particular type of traffic that works less good than others in the service mesh, like large files being passed around, or high volume, need for low latency, type situations?
The question is, repeat the question so I can repeat it.
So, like, in a network, your network performance can be affected by a lot of things. Right?
Yep.
And maybe you've got large payloads,
Yes.
or whatever,
Right.
or maybe it's super chatty and it needs to be super low latency. Like, are there situations where the service mesh just can't deliver?
Okay, so yeah, the question is depending on your payload, are there certain situations where the mesh can fail you? It can fail, yes. And the answer is, I haven't seen one, but we do allow you to you can configure. This is an Envoy thing, right? Like if you're going to configure Nginx, there's a couple of tweaks that allow you to do large payloads and things like that. Envoy, I don't know. There should be tweaks for that. I don't know them off the top of my head. I haven't seen it in all our mesh customers. I just haven't really. I mean, service to service stuff, east-west traffic. Do they generally? It's API traffic, generally speaking. I imagine there's some Envoy tweaks you can make. I don't know them, but most service mesh implementations should allow you to get into the Envoy.
Well, yeah, maybe more importantly, like, let's say, like today, this is a real life example.
Yeah.
We have teams coming to us saying the latency of Kong, because in their eyes is Kong, right?
Always.
Is taking all this time.
Yes.
And, and of course, their application, depending on where it is, if it's on-prem somewhere, there's a different set of firewalls and this, that, the other. If it's in Azure, it's a whole different ballgame, just be a whole nother one, right? So we've got to kind of trace down all of that so that we understand the various hops and load balancers and other things that potentially might be in there.
Mm-hmm.
And when we look at instrumentation in Kong, we see, Kong, and then we see other, like before and after, potentially.
Right.
Does the service mesh give you anything additionally on top of that, out of the box, where you could more definitively say this came from this load balancer that's in front of Kong, kind of thing?
So, the service mesh is going to give you. So first, it just goes back to the observability piece. If you ever looked at Envoy's observability metrics, what they're available, it's just a huge list of things. Latency is one of those things, and when you use that, all those metrics become available to you. And now you also know which service is talking to which. Each one of those, we stand in Prometheus in each data plane, and you can interrogate that Prometheus and get all of the different Envoy metrics for each service, and you can inspect that. So, okay, I know that this service and this service, here's latency. I know this service, so you can pinpoint it. Yeah.
But that's still only gonna give you what's inside the mesh.
Yes.
You have 50 switches in
Correct.
between, you still have to know that there's 50
Yes,
switches.
it's
Yeah,
gonna,
but some
it's, you,
switches aren't part of the mesh, right?
Well, no, I mean, that,
Well,
they're
no,
ignored
but
by the mesh. The mesh doesn't know about it because that's a network topology.
correct.
Yeah.
But you're gonna be able to pinpoint which service to
Yeah.
which service, and you may know, okay, I know what's going over the switch.
Yeah. Which
So
you
it-
could do that with gateways if teams
For sure.
diagram their networks and
Yes.
understood their networks. It goes back to the classic problem of people don't understand the networks. They blame the thing in the middle.
Yes.
And it's really like in my history of this stuff is the network's hardly ever the problem.
Yeah.
It's usually the software on both sides. Hardly ever the network problem.
But this isn't, the mesh isn't gonna give you any additional visibility. It's the same problem, right? It can't know about something that isn't instrumented in it, you know, kind of.
Right.
So.
Well, I mean,
it gives you a bit more of the is service A really talking to service B or is service A going to service C then to B? Gives you a bit more visibility on that because unless you go look line by line in the two problem servers or the one that's saying there's a problem with latency, the service mesh will at least give you the connectivity of who should be talking to who.
so you
That's where you get more observability, but you're right though, it still has the same problem of if there's an egress at the data center up to the cloud, still gonna be a problem that you don't have visibility on.
we do have like one of the, there's a stuff we do was it
Like Dynatrace.
We have
suffers from
this-
the same thing
so
too, right? If it's not
there-
instrumented, you know, embedded in it, it's not gonna.
there is a graphical representation. You can kind of actually see which service is talking to which. You know, so you can kind of get a visual.
Right, but if there's a firewall and a
Yeah,
load balancer.
but you have to know your network topology.
Yeah, right.
Back
Well,
to
I was hoping it would
Dynatrace
help.
gives you pretty graphs like this too, and
Yeah.
it's great
If you
know
don't-
the hops in between.
Right.
Right.
That black box of what hops are in between,
Yeah.
you're still at the mercy of people knowing their shit.
Right.
Stuff.
Poop. Yeah. Yes, you're correct.
The meetup just went R-rated.
It's we're all
I'm here,
adults.
it's all right. I can talk with you after the
Okay.
Awesome.
ideas.
So let me just fail that over just to kind of complete the demo because it's fun. I'm going to connect to my demo zone. I'm going to simulate catastrophic failure. Boom. I'm going to like to do it live in person. So let's do this here. I'll do this here. So we're operating at normal, and I'm going to scale. It's 08. Scale rest on 0. Boom. So now we've. So this is east. You know there was a little blip. Now it's just going to west on the fly, but the other one's isolated. So it self-healed. It self-resolved itself. That was the east ingress, right? But the west is unaffected. What's that?
I think you just accidentally closed your tab. Okay.
If you saw the here, the URLs are different. It's a Safari.
It
No
just
one
looked
likes-
like you accidentally clicked a little too far to the right and closed
Oh.
it instead.
Here we get these things out of the way. There you go. There's my. I think that's my east, and that's my west. You'll notice the west is still faster.
Yeah.
Okay, because the east is going across. So now we'll scale the guy. Now okay. Oh crap! The whoop machine goes off. We got a problem. We're still running. We've seen this. This actually happened in practice in one of our big customers selling tickets. It went down and they didn't miss a beat. They still sold tickets. So they fixed it. So then all we need to do is scale it way back up. Watch it kind of self-heal itself back to normal working order. So Redis is kind of coming up. Counter's going to reset to 0 because we're not synchronizing, but you know, 2A. There you go. And then west is still going strong. Questions, comments?
So do you still have that diagram up that had the two?
I can bring it up.
So my question is, so that Kuma global control plane, where does that typically run at?
Yes, if you're running open source Kuma, you would run that, you know, wherever you want. Just
Okay.
you know, it would be its own Kubernetes cluster. It's not part of the mesh.
Mhm.
It's more of just a component that manages the mesh. So you'd run it outside. You'd have its own. It'd have its own cluster. And if you're using our other product, Calm Connect, we run it for you. So, but yeah. Question is, where does the global control plane run? For all you people on YouTube, and it runs.
Which cloud are you in?
Yes, which cloud? Yes, this guy right here. This
So you could choose to put it in one of the regions if you wanted, or like.
Yeah, as long as it's in a separate, so it can't reside in the same cluster as the zone CP. It's got to be
Okay.
totally separate.
Okay.
Because you can't have each cluster has got to have its own control plane. So, like, if you think about what's going on, that zone control plane is responsible for standing up sidecars. So if you have two in one, it's not going to know which one to stand up. And the global control plane has to run totally outside of that. Because this line is a network connection that's an extension of the Envoy Discovery Service Protocol, XDS. So in Envoy, they have XDS, and there's a bunch of different extensions of that protocol. Kong wrote one called KDS, Kuma Discovery Service, which is basically applying policy, all those policies that I've been applying across that line right there. So we've extended the Envoy Discovery Service Protocol. It's a gRPC thing. So that's a secure gRPCS connection.
So in all of that, you were talking about troubleshooting these things in real time when, you know, there's a real problem, real traffic was coming in.
Yeah.
That's also why you want your control plane to be available, right? Because you know, and if it was down, your first step is to recover that, right?
Yeah, true, for sure. So yeah, and so when I was talking about you'd have multiple copies of those. One will be the leader, and you just run the load balancer to the many copies of the global CP.
So in each one of these zones, like Kuma CPU Zone West, is it the only control plane, or do you put multiple?
You can put
control
multiples. It's you can have multiples
Depends on
in
how
each.
big your mesh is over there. You could have 5 meshes in West, and they each have their own control plane.
Well, in Kuma, the mesh is our control plane is multi-tenant, single control plane for multiple meshes. That's one of the uniquenesses of Kuma. We don't use Istio under the hoods, so it's direct to Envoy.
So you talked a lot about Kubernetes and service mesh. What
Yep.
about virtual machines, traditional boxes?
Yep. So the question is, what about virtual machines or bare metal? And yes, we call in Kuma we call it universal mode, and it'll run just the same. You just have to manage that Kuma DP sidecar.
Right.
You just manage it yourself with your own automation. You just stand it up, and there's some Kuma CTL programs that will set up IP tables for you and things of that nature. So you
What
don't have
about unikernels?
Unikernel?
Yeah.
I don't know what those are.
We should talk.
All right. Man, I probably do, but not in name. We'll talk.
Yeah.
We do some kind of, I know Kuma does some eBPF stuff for like routing and things of that nature. We don't go totally sidecarless, but IP tables can be a little slow. So we have a routing mechanism that uses an eBPF, and the rest is handled in the sidecar. You can speed up performance by about 30%, I think, using that.
So what does rollout look like?
What does-
Sam running on Kubernetes,
Yes.
it's native Kubernetes.
Yeah.
And I want to transition to this.
Yeah.
What's that look like?
That's a great question.
Is it big bang or
No.
is there a slow roll?
Right. So the question is, what does rollout strategy look like? And it's not big bang. You don't have to do it. Okay. So when you enable, so we're talking about Kubernetes. Let's leave Universal out of it. That's a whole different ballgame. So basically what you do in Kubernetes is you can label a namespace, or you can label a pod, label a pod with a particular annotation called sidecar injection enabled. Once you do that, the control plane sees it, says, oh, this namespace is meshed. It will stand up the container in the pod that is the sidecar for you. Okay. Now what happens, so you can do that in a particular one pod in a namespace, right? So now what happens, I need to still communicate with stuff outside, and people still need to communicate in. Okay, this comes down to the gateway. The gateway is also a service on the mesh. Okay, the gateway will run a sidecar next to it. Okay, I always like my analogy that I always use with service mesh is like a stereo system. There's an input and there's an output. Input, you're hooking up components to a stereo, right? A gateway is a special type of component. I always equate it to a microphone. There's only an output because the input is the wide area. Because remember, in a mesh, all we're doing is we have an MTLS certificate. Data plane proxies can only talk if you have a certificate signed by the CA. But if you're on the gateway side, the external, they won't have that mesh, that certificate. But I still need to talk to, it's a gateway into the mesh. So the Envoy is, when you're running a gateway delegated service is what we call it in our terminology, there is only an outbound interface. The inbound is not protected by MTLS. So if an external service is not on the mesh, just go through the gateway and talk to all the services in the mesh. Now, in Kuma, there's also I need to go inside out, right? So we have a pass-through setting that you can enable or disable. So by default, traffic can communicate to the outside world freely using existing URLs and things of that nature. But you can also turn pass-through to false, which will tell you, oh, this service cannot talk to anything outside of it. It'll just block you, part of the ZTA stuff. And then you write a policy inside the mesh to say, oh, I'm going to allow this service to talk externally. So you can gradually have a strategy to gradually roll out these things. It's not a big bang thing. That's why when I said you want to start small with this stuff, to really get an idea of how this is going to work in your infrastructure. Because you can take out your whole application with this stuff. This is a low-level tool. You can really hose yourself up pretty good. It's a software that is not to be taken lightly. You got to really know how to do it. Otherwise, like I said, we give you enough rope to hang yourself with. So, good question. Does that help? Cool. Any other questions? Well, I think that concludes my demo. I hope everyone found it interesting and enlightening. So, appreciate your time.